The Milky Way galaxy alone has over 400 billion stars, many of them older than our Sun, many of them almost certainly orbited by planets. So here's the question that keeps physicists up at night. Where is everybody? Think about it this way. If you drove across the entire continental United States, from Santa Monica Pier all the way to Times Square, and you never saw another car, another gas station, another single light on the horizon, you wouldn't assume you were alone in the country. You'd assume something was very, very wrong. That is exactly where we stand with the universe right now. And the silence out there? It might not be peaceful. It might be terrifying. Welcome to SPAC Secrets, the channel where we take the biggest questions in space and physics and break them down so clearly you'll feel it in your bones. I'm so glad you're here today, because this one is going to change the way you look up at the night sky forever. Stay with me all the way to the end, because the full picture of the Fermi Paradox only lands when every piece clicks into place. And if questions like this light you up the way they light me up, hit that subscribe button, because we do this every single week. Now, let's talk about the scariest truth in our universe. The observable universe contains an estimated 2 trillion galaxies. 2 trillion. And our galaxy alone, the Milky Way, holds somewhere between 200 and 400 billion stars. Many of those stars are older than our Sun by billions of years. Many of them have planets. Many of those planets sit inside what astronomers call the habitable zone. Not too hot, not too cold, the kind of cosmic sweet spot where liquid water can exist, where chemistry can get interesting, where life, at least life as we understand it, has a fighting chance. Run the numbers honestly, and the universe looks absolutely packed with potential. So here's the question that has haunted physicists, astronomers, and some very serious people at NASA for decades now. Where is everybody? Think about it like this. Imagine you moved into a brand new neighborhood. Hundreds of houses on every block, lights on in the windows, cars in the driveways, every sign that people are home. But you knock on every door for years and nobody answers. No sound, no movement, nothing. You would not conclude the neighborhood was empty. You would conclude something deeply strange was going on. That is exactly where humanity stands right now in this universe. Since 1984, the SETI Institute, based right here in the United States, has been systematically scanning the sky for radio signals, laser pulses, any detectable sign that someone out there is transmitting. NASA's Kepler Space Telescope confirmed that planets are not rare. They are everywhere. The James Webb Space Telescope is now analyzing the atmospheres of distant worlds looking for biosignatures, the chemical fingerprints of life. And after all of it, the listening, the searching, the most sophisticated space discovery technology our civilization has ever built, the universe has sent back one thing: total silence. Not a whisper, not a signal, not a single confirmed contact in the entire history of human science. That silence has a name. The Italian-American physicist Enrico Fermi captured it in one devastatingly simple question back in 1950, sitting at a lunch table at Los Alamos National Laboratory in New Mexico. If intelligent life is so probable, then where is it? We call it the Fermi Paradox. And the deeper you look at it, the less it feels like a puzzle, the more it feels like a warning. To understand just how serious this warning might be, we need to look at the one equation that tried to put a number on the universe's population and what that number might actually mean for us. In the summer of 1961, a group of the brightest scientific minds in America gathered at the National Radio Astronomy Observatory in Green Bank, West Virginia. They were there to do something that had never seriously been attempted before. They were going to try to calculate how many intelligent civilizations might exist in our galaxy right now, actively trying to communicate. The man who wrote the equation was a young astronomer named Frank Drake. And what he put on that chalkboard that day was not just a formula. It was humanity's first honest attempt to measure our place in the cosmos. The Drake equation works like a funnel. You start wide and you narrow down. You begin with the rate at which new stars form in the Milky Way. Then you ask how many of those stars have planets. Then how many of those planets could support life. Then how many actually develop life. Then intelligence. then technology capable of sending signals across space. And finally, how long do civilizations like that actually survive before they go silent? Some of those numbers we now know with real confidence. Thanks to NASA's Kepler Space Telescope, we know that planets are extraordinarily common. In fact, astronomers now estimate there are more planets in our galaxy than there are grains of sand on every beach in the United States combined. That is not poetry. That is a genuine science fact backed by hard observational data. But here is where the equation gets uncomfortable. The last variable, the one that asks how long a technological civilization survives, that one we can only answer by looking at ourselves. And when you look at human history honestly, at our wars, our weapons, our climate, our track record as a species, that number starts to feel a lot smaller than we would like. Plug in optimistic values across the board, and the Drake equation tells you the galaxy should be buzzing with civilizations. Plug in realistic ones, and the number drops. Plug in brutal ones, and you are left with something deeply unsettling. The very real mathematical possibility that advanced civilizations have a ceiling. That something stops them. Every single time. Scientists call that something the great filter. And whether it is behind us or still waiting ahead of us is honestly one of the most important questions the human race has ever asked. Let's sit with that idea for a moment. The great filter. It sounds abstract, but what it really means is this. Somewhere between dead chemistry and a civilization that can cross the stars, there is a wall. A barrier so difficult, so catastrophic, so final, that almost nothing gets past it. And the terrifying part is not that the wall exists. The terrifying part is that we do not know which side of it we are standing on. Think about it like climbing a mountain. Imagine you are hiking up a trail in the Rockies and you know that somewhere on this mountain there is a cliff face so sheer, so vertical, that virtually nobody who reaches it makes it to the top. The question that should keep you up at night is not whether that cliff exists. The evidence strongly suggests it does. The question is whether you have already passed it without realizing it, or whether it is just around the next bend. For humanity, the optimistic case goes like this. Maybe the great filter is behind us. Maybe the hardest step was the very beginning. The jump from simple chemistry to the first self-replicating molecule, the birth of complex cellular life, the leap to multicellular organisms. These steps took billions of years on Earth and may be extraordinarily rare across the universe. If that is true, then we are the lucky ones. We cleared the wall. The silence around us is not a warning. It is just the sound of an empty track, and we are out front. NASA's astrobiology research takes this seriously. Scientists studying extremophiles, organisms that survive in the most punishing environments on Earth, from the boiling hydrothermal vents on the ocean floor to the frozen deserts of Antarctica, are actively trying to understand just how improbable the first spark of life really was. The harder it turns out to be, the more the great filter looks like something we already survived. But here is where the science gets genuinely chilling. If we send a rover to Mars, or if the James Webb Space Telescope detects biosignatures in the atmosphere of a distant exoplanet, and we find life, even simple microbial life, that discovery would be one of the greatest moments in human history. And it would also be, quietly, catastrophically bad news. Because if life arose independently twice in our own solar system, it means the early steps are not rare at all. It means the filter is not behind us. It is ahead, waiting, for everyone. That realization leads us straight into one of the darkest and most brilliant ideas in all of modern cosmology. The possibility that the smartest thing any civilization can do in this universe is never make a sound at all. There is a thought experiment that once you hear it, you cannot unhear it. Imagine you are alone in a vast, dark forest at night. You do not know what else is in that forest with you. You do not know if the other creatures are friendly. You do not know their intentions, their hunger, or their size, or their... You have two choices. You can light a torch, make noise, and announce yourself, hoping that whatever is out there is peaceful and wants to connect. Or you can move silently, stay invisible, and survive by never being found. Now scale that forest up to the size of the entire universe. And suddenly the silence starts to make a very different kind of sense. This is the dark forest hypothesis, and it is one of the most unsettling proposed solutions to the Fermi paradox in all of modern cosmology. The core logic is straightforward and brutal. Resources in the universe are finite. Stars burn out. Planets are limited. Any civilization advanced enough to travel between star systems is advanced enough to understand that every other civilization is a potential competitor. And in a competition where the stakes are survival, the only rational move is to strike first, or stay completely hidden. Under this model, the universe is not empty. It is full. Full of civilizations holding their breath, lights off, perfectly still, listening for anyone careless enough to broadcast their location. And here is the part that should make every American space enthusiast genuinely uncomfortable. We have not been quiet, not even close. Since the mid-20th century, Earth has been leaking radio waves into space at the speed of light. Every television broadcast, every radar pulse, every military transmission, all of it expanding outward in a growing sphere of electromagnetic noise centered right here on our planet. The earliest episodes of I Love Lucy are currently passing through star systems roughly 70 light-years away. We have been announcing ourselves to the cosmos for decades without a second thought. NASA scientists and researchers at institutions like the SETI Institute have openly debated whether actively transmitting powerful, directed signals toward other star systems, a practice called METI, Messaging Extraterrestrial Intelligence, is something humanity should be doing at all. Some of the most serious voices in American astrophysics have argued it is, at minimum, worth a very careful conversation before we shout any louder into the dark. Because if the dark forest is real, the civilizations that survived long enough to become truly advanced did so by one method above all others: silence. And right now, for better or worse, we are the ones with the torch lit, standing in the middle of the trees, wondering why nobody is calling back. But what NASA's most powerful telescopes are beginning to detect may finally force us to confront the answer head-on. Right now, at this very moment, a telescope the size of a tennis court is floating nearly 1,000,000 miles from Earth, peering into the atmospheres of planets orbiting other stars. The James Webb Space Telescope, built by NASA, launched on Christmas Day 2021, and representing the combined scientific ambition of an entire generation of American researchers, is doing something no instrument in human history has ever been able to do. It is reading the chemical fingerprints of alien worlds, breaking starlight apart as it filters through distant atmospheres and searching for the signatures of molecules that, on Earth, only exist because of life. We call them biosignatures, things like oxygen, methane, nitrous oxide, chemicals that have no business being stable in an atmosphere unless something biological is actively producing them. And the James Webb Space Telescope is already returning data on exoplanet atmospheres that has the scientific community holding its breath. Here is why this matters so deeply to the Fermi Paradox. Think of it like a crime scene investigation. If you walk into a room and find no fingerprints, no footprints, no DNA, you might conclude nobody was ever there. But the moment you find one piece of biological evidence, the entire investigation changes. Suddenly you are not asking if someone was there. You are asking who and what happened to them. That is exactly the investigative shift that a confirmed biosignature detection would trigger for humanity. One positive result from Webb, or from a future mission like NASA's proposed Habitable Worlds Observatory, would not just answer the question of whether life exists beyond Earth. It would reframe every single theory about the Great Filter, the dark forest, and the silence we have been swimming in since Fermi asked his question over 70 years ago. Because here is the brutal science fact at the center of all of this. The universe is approximately 13.8 billion years old. Our civilization is roughly 10,000 years old, technologically capable of space communication for less than a century. If life is common and intelligent civilizations are common, some of them had a billion-year head start on us. A billion years. The fact that none of them have reached us, colonized our solar system, or left any detectable trace anywhere we have looked is not just strange. It is a data point, and data points tell stories. The story this one tells has several possible endings. Maybe we are genuinely, improbably alone. The first ones, the rare ones, the cosmic accident that somehow made it this far. Maybe the filter is behind us, and the road ahead, as terrifying as it looks, is actually open. Or maybe the silence is not emptiness at all. Maybe it is the sound of everyone else having already learned the lesson we have not yet faced. Whatever the answer turns out to be, one thing is certain. The search that NASA and the global scientific community are conducting right now, in real time, with real instruments pointed at real stars, is the most important investigation our species has ever undertaken, and we are alive at exactly the moment it starts to deliver its verdict. So let's bring this all the way home. We started today with a question so simple it fits in one sentence. The universe is ancient, vast, and statistically overflowing with the conditions for life. So where is everybody? And what we found when we followed that question honestly, through the math of the Drake equation, through the brutal logic of the great filter, through the chilling silence of the dark forest, is that the absence of an answer is itself one of the most important answers in all of science. Here is what you now understand that most people walking around today do not. First, the silence is not nothing. It is data. In a universe this old and this large, silence at this scale means something happened. Everywhere, repeatedly, to civilizations that may have been millions of years more advanced than us. Second, finding simple microbial life on Mars or in the atmosphere of a distant exoplanet would not be a victory. It would be a warning, because it would mean the filter is not behind us. It is still ahead. And everything we have built, everyone we have ever loved, every city skyline and every NASA launch and every moment of human progress, all of it would still be on the wrong side of whatever ends civilizations. Third, and this is the one that stays with you, we are not passive observers of this mystery. Right now, NASA's James Webb Space Telescope is scanning alien atmospheres. The proposed Habitable Worlds Observatory is being designed in American laboratories to go even further. The answer to the Fermi Paradox may not arrive in a science textbook 100 years from now. It may arrive in a press conference, in our lifetimes, on a Tuesday afternoon. And when it does, the most important question will not be whether we found life out there. It will be what that discovery tells us about what is still coming for us down here. Think about that the next time you look up at a clear night sky from your backyard, from a highway in the Nevada desert, from a rooftop in any American city. Every single star you can see is a data point in the most important universe mystery our species has ever tried to solve, and you now understand exactly why the answer, whatever it turns out to be, might be the most profound and terrifying science fact our civilization has ever confronted. We are the ones asking the question. Let's hope we are still here when the universe finally answers. If this video made the cosmos feel a little bigger and a little more urgent, then we did exactly what Astro Matt is here to do. Take the deepest ideas in space exploration and physics and make them feel real, clear, and genuinely alive for you every single week. If you are not subscribed to Astro Matt yet, right now is the moment. Hit that subscribe button and join a community of curious minds who refuse to look at the night sky the same way twice. New videos drop every week, and trust me, where we are going next is just as mind-bending as where we have been today. Thank you for watching. I will see you in the next one. Hey, thank you so much for spending this time with me today. It genuinely means a lot. And listen, the fact that you now understand why finding microbial life on Mars might actually be bad news for humanity rather than good news, that is not a small thing. That is one of the deepest ideas in modern science, and you just got it. This is exactly why NASA's work matters so much right now. Every atmosphere Webb analyzes, every rock Perseverance turns over on Mars, every signal SETI scans for, it is all building toward an answer that could redefine America's entire future in space and what we decide to do next as a civilization. I love exploring this stuff with you, genuinely. There is nothing quite like sitting with a question this big and actually feeling it land. I'll see you in the next one.